Hello there, I thought I'd make a little demonstration of a little program that I created called the Enigma Morph Encoder. Now what it does is it encodes your messages in order to prevent them being read by anybody that doesn't have this program and also know whatever key phrase you use. Now this is the README file which you'll get with the program if you were to download it, and I'm just going to take this example message from the README file and paste it in here and click encode. You'll notice the message, "Dear Jane, I hope you're well," has encoded into this. And also you'll notice that the second character here is the letter E, and the 9th character is an E, whereas here the second character here is a P, and the 9th is a 2. Now if we carry on, 10, 11, 12, 13, 14, 15, 16, the 17th character is also an E. Now if we look at here, we'll notice the 17th character is an E, so that here we can see an E is actually encoded to itself. Now that's not a flaw, that's a good thing in fact, because one of the things that helped the British crack the German Enigma codes during the Second World War was a weakness that it had, because none of the letters in the encoded message were ever encoded as themselves, so such as in this case an E would never be encoded as itself. Now that flaw was a weakness that the British were able to exploit and help them crack the Enigma codes during the Second World War. You can't do that with my program here, the Enigma Morph Encoder. And just to show you that this does encode, as I've got a second copy of the program open up, I'm going to paste the encoded message here, click decode, and you'll notice, "Dear Jane, I hope you're well." Now I'm going to take another example message from the README file, and you'll notice it's pretty much the same as the original message. Here it's the original message was, "Dear Jane, I hope you're well," and the only difference is the "from John" at the end. Now we're going to encode that. Now you can compare how they've encoded, and you'll notice that despite the fact that the first 31 characters are exactly the same as the original message, it has encoded them completely different. There is nothing there's nothing the same with this encoding as to the original encoding. If you look at the original encoding, which is this, what we've got here, to this, there's no way you'd be able to tell looking at that they were in fact 74% identical. So that's another thing that's good about this program, whereas a lot of encoding programs and machines, if the first part of the message is identical and if you use the same key phrase and same settings, it would encode the first part of the message exactly the same if they started the same. This does not happen with the Enigma Morph Encoder. It will generate a completely different encoded message. And we can paste that into here and click decode, and you notice it does decode exactly as you would expect. As well as that, you'll notice that all the messages that are encoded, it retains all spaces in the program, as well as punctuations such as the commas and the full stops here and here. So there you have it. That's my Enigma Morph Encoder, and also what you have here is the encryption depth. Now what this is it's the number of times it passes it through the encryption algorithm. So if we can pass that same message through 10 times, and again completely different message. But what if we just keep it at 1, just to show something else? We've put a lowercase t in the key phrase, and we're going to click encode. Put it in there and decode it, and you'll notice it's completely gibberish, and the only difference is we didn't have the lowercase t in the key phrase. So now we've corrected that, click decode, and it decodes it correctly. So the key phrase is case sensitive. All actual messages are all turned to uppercase, and unfortunately that's unavoidable, but the key phrase is key sensitive. So, and also the punctuation is included in it doesn't ignore punctuation or anything like that. It uses it all to build up the encryption matrix. This little checkbox here, all that does is, you'll notice if I click encode now, it's the same alphanumeric characters but without the spaces in between, because when you don't have that checked, it puts a space every 10th character. So basically the output is in blocks of 10. So I can see here that the output here is exactly 60 characters. Now if you want to download this program for yourself to use, and it could be that you just don't like Gmail reading your emails to put ads in it, or perhaps you don't want your employer reading emails from your boyfriend, girlfriend, husband, wife. It will enable you to keep all your messages totally private. And this is the address where you can download it. That's www.zippyshared.com/v/800-72273/file.html. Now I'll put that link in the description as well. So hopefully you've got a use for this, and the program is totally free. It's a small file too, it's only I think 34 kilobytes, so not very big. Please feel free to share it with your friends, and as you can see at the moment it's just version 1. If any future changes happen, I will annotate it here on the version number. But going forward, if there are any changes, you will need to make sure that anybody that using it is using the same version number as you, because I can't guarantee that it will encrypt exactly the same each time the version changes. So there you have it. Thank you very much for watching. Goodbye.